In this video, we're looking at the trigonometric ratios. So there are three special fractions that we call trigonometric ratios, and these relate to the lengths of two sides of a right angle triangle. These are known as sine, cosine, and tangent. So sine is found by using sine theta, remember theta represents an unknown angle, equals opposite over hypotenuse. Cosine is cos theta equals adjacent over hypotenuse. And finally we have the tangent, which is tan theta equals opposite over adjacent. So again, remember, theta is just an unknown angle. Alright, now when we're talking about opposites, hypotenuses, and adjacents, we're referring to a triangle where we have a given angle. So over here would be our opposite, O, our hypotenuse, and our adjacent. Alright, so how we like to remember it is so ka toa. This is my favorite one. So ka toa, where so is sine, opposite, hypotenuse, and then you have ka, which is cosine, adjacent, hypotenuse, and finally we have toa, which is tangent, opposite, adjacent. Alright, so whenever you're doing these type of questions, it's a good idea to write so ka toa at the top of your page so you can refer back to it and help you jog your memory about which one's sine, cos, which sides are in sine, cos, and tan. Alright, so we're going to jump in some questions. For each marked angle, find sine, cosine, tangent. So we have a marked angle here. So the first thing you should do always is label your sides. And what I mean by that is find your opposite, adjacent, and hypotenuse. So remember, your hypotenuse is always straight opposite your right angle. So this is my hypotenuse. Your opposite is a straight line leaving your marked angle. And then finally, since we have O and H already, this must be our adjacent. So if we're doing our sine, over here, sine, remember sine theta is opposite over hypotenuse. So in this case, what was our opposite? Our opposite was 7.7. So at this point, we're just substituting in. Hypotenuse was 8.5. We then can do cos theta, which was adjacent over hypotenuse, because ka. And then finally we go, well, what's my adjacent? That was 3.6 over my hypotenuse, which was 8.5. And we finally do our last one, which is tan toa, so OA. So tan theta equals O over A, where O is 7.7 over our adjacent, which is 3.6. And we've just done all our trigonometric ratios for that triangle. So here's another one. So before we begin, I want to make sure I know all my sides. So this is WY because it's joining our W corner and our Y corner. Here's XY, and finally here's WX. So straight line from our right angle, so that must be my hypotenuse. Straight line from my angle, that must be my opposite. And the last one means this is my adjacent side. So ka toa, so sine theta equals opposite, so which was my XY, over my hypotenuse, which was WY. We then do cos, which is adjacent over hypotenuse. Adjacent side is WX over my hypotenuse, WY. And lastly, we have tan theta, which is opposite over adjacent, so XY over WX. Alright, so to end the video, we'll do a recap. So remember, sine is opposite over hypotenuse, and we use so for that one. Then we have cosine, which is adjacent over hypotenuse, and we like to use ka to remember that. And finally, tangent, which is opposite over adjacent, and we use toa. So ka toa is the way you try to remember these trigonometric ratios.